Hello, everybody. I just had the best Keebler chocolate chip cookie. It was so delicious. Have you had one today for yourself? Well, if not, then I totally recommend them. They're wonderful. Okay, so I hope you can just spoil yourself and just pamper yourself and just have some cookies, right? Enjoy and and live in the moment, right? So speaking of chocolate chip cookies, we have this interesting problem here. Um, that talks about Keebler cookies, all right? And a part, it wants us to refer to data set 39 and find the mean number of chocolate chips in the 34 Keebler cookies. All right. Okay, to do this one, data set 39 is in this program that we call StatCrunch. StatCrunch is a very, very powerful statistics program that I totally recommend. All right, and here we have in my lab statistics, StatCrunch. We're going to open up the data sets from our textbook right here by clicking on this link. And it wants us to look up data set 39. So we'll click on this arrow right here and then scroll down and we'll look for 39. And it's right here, 39 chocolate chip cookies. So click on that. And we want Keebler, which is in this column right here. So to find the mean, we're going to go to Stat, and then Summary Stats, and then click on Columns. All right, and we're interested in the Keebler column, and we'd like to find the mean, which is right here. So we'll select Keebler and select Mean, and then click Compute. And here it is right here on the right-hand side. We have the mean here of 30.411765. All right, so let's answer the A part then. So the mean is 30.411765. And so that's going to be in chocolate chips. Now I've seen chocolate chip cookies with maybe 5 chips or 10 chips. But having 30 chips on one cookie is pretty cool. I like it. Okay. That would certainly get my that would certainly please myself for sure. All right. So we have that right there. And then now B part. Now it wants us to assume that the Poisson distribution applies, and the Poisson distribution really applies for some continuous interval. So in this case, we're talking about a continuous interval of cookies. All right. Now, if you go from one cookie to the next cookie, it's not really continuous, but it should be close enough. All right. So that's why we just have to assume that the Poisson distribution applies. And using that, we're going to find the probability that a Keebler cookie will have 26 chocolate chips. Well, since 26 is pretty close to 30.411765, it might be a high probability. On the other hand, 26, there's a lot of numbers between 26 and 30.411765, so it might be a low probability. Well, at any rate, we have the Poisson distribution formula right here. Okay, so it says P of x is equal to mu to the x times e to the negative mu all over x factorial. Okay, so in this case, we're dealing with 26 chocolate chips, and so x is 26. So this will be P of 26 is equal to mu, that's the mean we got in A part, it's 30.411765. And this is raised to the x, which is 2 to the 26. And then times e. So we'll just go and keep e in there for now. And then to the negative mu, that's going to be to the negative 30.411765. And this is all over x factorial. So this is all over 26 factorial. Okay, now we're going to use the Desmos calculator to simplify this, especially since Desmos understands E and also understands the factorial notation. So we just have to just put that in there. Okay, we'll do that to the 26. To get an exponent, we'll click on this A to the B button, 26, and then times, we'll hit the times symbol, which is right here. And then to the E, just type in E, and then to the negative 30.411765. Okay, now we're going to get the cursor out of the exponent field by clicking on the right cursor key. Okay, now we want to put that in the numerator of our fraction. So to do that, we'll type in close parentheses, and automatically puts an open parenthesis in the beginning there. And then we'll type slash, and it puts it in the numerator. And then we'll put this over 26 factorial. And here's the answer right here. It's 0.05569311167. All right, so that's the probability. Okay, it's a pretty low probability. That's mainly because there's a lot of other possibilities besides 26 to look at. In other words, we can analyze 27 chips or 29 chips or even 10 chips. So there's some other numbers that we could have besides 26, which explains why this probability is rather low. However, since this number is more than 0.05, 26 chocolate chips is not significantly low. It's not significantly low. All right. Okay, all right, so that's the B part there.